Assalamu alaikum. Welcome to this new video in which we will see the use of different statements. We will use three statements as in examples and one always block. The other two statements are if statement and conditional statement. If statement, conditional statement are a bit same, but they have a different implementation in the code. So what is assign statement? Uh, we will see it from the code because all that matters is the difference in implementation. This first part is obviously same, but the statement, actually the statement that is assign statement is the actually the difference in the code. We say that there is an input D and an other input select. So we say, as we know about multiplexer very well in the last previous two videos, that how a multiplexer works. It is basically dependent on the selection line. Okay, the selection line will decide which of the output, what output will be displayed in the output. So we will implement this code as it is in the Quartus and show you the implementation. Let's create a new variable Verilog HDL file. Name is as our project name. I think we shouldn't have given it the name that is built in. We will save this as assign example. I think this must work now. Let's compile it. And until compilation we will have a small break. Upon successful compilation of the code, we will first see the RTL viewer for gate implementation. So it gives us a mux and it has a unique implementation. Now we will go to the confirmation of our code according to the concept which we have, that if select is 0, it will give D0, and according to D0 Q will be implemented. That is what is given in the assign statement, that if select is 0, it will give D of 0, and that D of 0 will be assigned to variable Q. Let's see in the simulation. We give select, it is a 2-bit, so if we give it a 0 0, okay, and input D, if D0 is let it be like this, and confirm whether it confirms the first case where both are 0 and the output is 1 given from here. Let's compile it and confirm it from here. So we see a low, as we have given d0 a low. So now let's see if we give d0 a high. So I predict that since the first gate will be a high and we give the selection as 0 0, so our output q will be a high. Let's see. Exactly, wonderful. So we say that selection lines are 0 0, and we give the gate 1 or d0 a high, then we get a high in the output. This is the same exact same implementation. In the previous video we have discussed three methods, and we gave different cases to these. There was case statement, there was gate flow implementation. So we again confirmed our result, and we will let's give it another try, and we will see another example. If we give our selection line as 1 0, let's say, then I predict that this gate 3 will be uh, activated. So to confirm it, we can do one more thing. Let's give it a low and all others are high. So if the output is a low, it will be confirmed that the gate 3 is selected by the selection lines. If the output is low, then it means that this one is implemented here. Yes. Exactly. This low is shown in the output. So that's it for now. Now the second example is of always block. What is always block? Basically, we have discussed earlier the use of always and bridge together. It is basically a statement in which any of the inputs, if any of the inputs are high, okay, then it will give that high or low input of select as a function of d input, and assign that function value to q. That is the same as we have implemented earlier in this assign statement, but instead of assign q is equal to d, there is always statement, and this statement is implemented here like that. We will confirm it in our Quartus and see how it gives our waveform, and we will see it has no difference than the previous methods, other than the writing the code in a different way. Yet we have done that mistake again, and we have learned earlier that we cannot use the words that are the variables or that operators that are inbuilt. So we will change the name again. So we have changed the name of our project so that it is not contract, it is not same like the one that is built in. So we'll give it a time for compilation. On successful compilation, we will now see the RTL viewer where it will show its gate implementation. It is same as before that we have saw in our previous example. This assign statement. Only the code is different, and we will also confirm it from our waveform simulation, and you will see that we have a same implementation. The select line from the code, we see that we have two inputs, select and D, and this statement will decide which which one of the gates will be allowed on the output to show its input as an output. We see the same pattern. We are given two selection lines. We give it 0 1 this time. Okay, 0 1, and we know that on 0 1 which gate will be allowed, the second gate will be allowed to show its output in the show its input in the output. So the second gate is this one. If we give uh, all these gates a high and give the second gate a low, then we predict that the output should be a low. So let's see, run the simulation. Exactly. It has allowed the second gate to show its input in the output. So we have confirmed our results successfully. The third example in this video we will discuss is use of if statement. So from above examples, it is the same implementation, but the difference is just the syntax. We see that all this is same. Reg why we use reg is for the always statement. Now the difference is begin the if statements. So what these mean, we will discuss it in the compiler. Let's copy this into our compiler in an HDL Verilog HDL file, and we will discuss it in a proper way. Now we say that if the selection line is 0, this operator is used. If selection line is 0, then assign the function d of 0 to q. And what is d of 0? We will see it in the simulation waveform simulation time. If it is 1, assign it to q. If it is 2, assign this to q. So this is basically the same implementation, and it will be confirmed in the RTL viewer also, and in the waveform also. Let's compile it, and it will take some time, so let's stop the video. So we have successfully compiled our code, Let's see in RTL viewer its gate implementation, and this is the complex gate implementation, but same. One selects two select lines and four inputs and one output. So this is basically the gate implementation for if statements. Now we can confirm our result from waveform screen, waveform simulation, and we are given with two selection lines and four gates. So again, this time we can give it a too high, which in 4 to 1 demux, 4 to 1 multiplexer, we see that the fourth gate is activated and its input is given to its output. So we predict that all the others, if all others are high, and the fourth one is low, then the output should be a low, because the input of fourth gate should be displayed or allowed to be displayed on the output. Exactly, the output is same as the fourth gate's output because all other gates were high. So if these selection lines couldn't allow this fourth gate to present its output in the in the out, then it would not give the same result as we have got. So this was if statement. We will now move to the last example of our today's video. Now the last example is use of conditional statement. So this conditional statement explains that if the select is 0, then the function q, then the function d of 0 will be assigned to q, and same as we have discussed earlier, but the syntax assign is basically different from previous examples. Let's copy the code into a Verilog SGL file and change the name to our project name control, sorry, conditional state. Let's compile and come back with a ready code. We've successfully compiled the conditional statement code. Now we will show its gate implementation. It gives different shapes every time, but the one thing that is common are four inputs, two selection lines, and one single output. That doesn't matter that how it implements through different RTL viewer. Now we will show simulation and confirm our 4 to 1 multiplexer phenomena, or how it works, and that is same that there are two selection lines, four inputs. Let's this time give it 0 1, which is basically which allows the second gate. 0 1 basically allows the second gate to show its input in output. So we will keep this one low and all other gates input is high, and we predict that the output should be a low. So let's compile it. Exactly. So we see that the code is correctly implemented here, and the output is same as the second gate input was there, and the selection line sequence 01 has selected the fourth, has allowed the second gate to show its input and the output. So this was it, and in this video we have implemented the second part of lab 4 of our DLD lab, in which we have implemented different ways of coding, of making a multiplexer or implementing it in Verilog HDL. And in this video particularly, we have discussed 4 examples of how we used these three methods in different ways to implement our 4 to 1 multiplexer. And do remember to watch the previous 2 videos on multiplexer, the basic idea of multiplexer, and the 3 different methods of implementing multiplexer in Verilog HDL. That is it from my side. Thank you very much. Allah Hafiz.